Okay, so in this one we're going to extend the previous problem and look at how you would deal with a limiting reactant. So in this case we've changed, it's the same reaction, the methanol, just like the stoichiometry, methanol reacting with oxygen to form carbon dioxide and water. In this case I'm just going to start with the balanced reaction, given that I solved it in the previous video. If you want to see that, you can go back. But we have here 2 CH3OH, 3 O2, 2 CO2, and 4 water. Okay, that's going to become important as we go through and do our calculations here. So the first thing I'm going to do is, I already know the 20 milliliters of methanol, multiply that by the density to get grams, multiply that by 1 over the molar mass to get the moles, and then you convert that by multiplying by moles of H2O over moles of CH3OH from the equation, multiply by 18. So if you look at the previous video, you can have that done out, but I'm simply going to skip ahead here and just say that the 20.0 milliliters of methanol, CH3OH, that's going to end up in the end being equal to 17.7 grams of H2O. So now what we need to figure out is how much can we make off the oxygen. So we're going to start with 20 grams of O2, and the first thing we're going to do is our usual, go to moles. So 1 mole of oxygen. In this case it's molecular oxygen, 2 of them, so it's 32.00 grams. Now I need to convert to moles of water. You notice that there are 4 moles of water for every 3 moles of O2. So I'm going to multiply by 4 and divide by 3. And I know that it is 18.02 grams per mole of the water. Okay, so when I do this out, I then get an answer that is 15.0 grams when you go to 3 sig figs of H2O. So if you take a look at that and note now what it means that we have 15 grams of water, we have 17.7 grams of water made by the methanol. So the 15 grams of water here, this is the least amount, and that means that we're going to run out of oxygen first. So that right there is our limiting reactant. Okay, and that means that how many grams can we actually produce? We can produce 15 grams of the water. Let's say we then were interested in trying to figure out what we are going to be dealing with in terms of the leftover. How much leftover methanol is there going to be? Well, we can simply look and say, well, I should have been able to make right here 17.7 grams of water, but I actually only made 15. So there's sort of a 2.7 grams of water right there. So there are 2.7 grams of water, and this is grams of water that I could have made if I had enough oxygen, but I didn't, so I couldn't. So this is sort of the difference in how much methanol we have left, right? This is the methanol, the water that would be made from the methanol that we couldn't use. So I'm going to actually just back this out now and figure out how many milliliters there are. So I take that water and I'm going to turn it now back into moles of water, 18.02 grams. And I'm going to convert that back over to methanol, and there are 2 CH3OHs for every 4 H2Os from the equation. And then I'm going to convert that by multiplying by 32.04 grams per mole, which is the molar mass of methanol. So at this point now we have grams of methanol, and then I simply do 1 milliliter over 0.791 grams, right? Grams. Now I'm left with milliliters of methanol. So you calculate that out, and it comes to 3.03 milliliters of methanol remaining. So that is how much methanol we have left over at the end of this reaction. We didn't use 3.03 milliliters of the original 20. Another way of looking at that is you can say that we used 16.7 milliliters of our methanol to react all 20 grams of the oxygen. So that's how you do a limiting reactant. You find out the grams that one could make, the grams that the other could make, and then you can use those to find the excess.